Hello, everybody. Oh, there's an echo. Hey, first of all, thank you for choosing our session. We realize you have so many sessions to choose from, and we really appreciate you taking the time and coming to our session. You know, I was thinking this morning about hybrid, and first of all, it's super exciting for the Azure Stack team to be here at Ignite. This is our 1-year anniversary since we had released the product. And it's super exciting to see what our customers are actually doing with Azure Stack. So this session is to give you an overview of what type of hybrid applications you can do using Azure and Azure Stack. Now, I'm just going to set some expectations here. Both Anjay and I, we will walk you through some code. There will be 98 slides plus, no 98 slides. So that will be code. There will be some demos. And through our demos, we will show you the different pieces that may comprise a hybrid solution. So, sit back, enjoy. And again, I'm Ricardo. I'm program manager on the Azure Stack team. And you are?
Hi.
They can hear you, yeah.
Hi, I'm Anjay Joda. I'm a PM on the Azure Stack team as well.
Great. So, all right, the first thing for us to think about it is look at the Azure and how Azure is available not only throughout the world, but also at the edge with Azure Stack and the other Azure offerings. So Azure Stack is an extension of Azure. And before I move forward, just some show hands here. Who had the chance to watch Natalia's and Jeffrey's Nova session yesterday? All right. So for those of you that did not watch that session, I highly recommend you, at the end of this session, we'll have a list of everything Azure Stack related. I highly recommend you guys check it out. That gives a great overview of the edge. And the edge is about really opening new opportunities of having computation and solutions in places where 5-10 years ago we would not expect. So Azure is present has a global presence. Azure also has many different flavors or Azure clouds. There is the government cloud. There is the different national clouds of Azure. And then there is Azure Stack, and there is all sort of the Azure-enabled devices that extend the reach of your solutions to the edge. And what that means is that you are empowered to design and develop your solutions in one way, which is the Azure way, and then basically leverage not only the public computation on the public cloud, but also having computation where action happens. And where action happens may be a factory floor, it may be a remote operation in remote sites all over the world. It can be on places where data sovereignty and regulations require you to keep your data in a certain location. And that's a huge differentiator of the Azure platform, which is basically allowing you to design your solutions in a standardized way and then choose which parts of the solutions land where. And that's what our session is about. Our session is about to show you some ideas and some use cases of how you can create applications that goes beyond the Azure public cloud all the way to your data center and vice versa. Now, if we look at some of the key value, key characteristics of Azure Stack, right? So we look at Azure Stack, and we do have the ability of running a hybrid cloud, either in a connected or disconnected fashion. What that means, a connected fashion means that you can run Azure Stack inside your data center, where you may have connectivity to the public cloud. A disconnected scenario means running Azure Stack in a place where connectivity is not present, or connectivity is intermittent. Maybe a scenario where you are, as I mentioned before, doing remote operations in a remote site, for instance. For those of you that watch the keynote with Julia, presented a demo that included Azure Stack. And that demo was basically a disaster relief solution that was designed to be mobile, to run on places where a mobile operation would be in progress. So that's one example of a intermittent connected operation. And also, going back to that particular demo we present, you also notice that there was a remote assistance demo that followed with HoloLens to basically provide workers with information on the tip of their hands. So all those things just reinforce the value of the Azure cloud. These are different components of the Azure cloud running in different places. Now the model, the application model. So one of the things that is very important when we design applications is to basically be able to leverage your existing knowledge, reusing artifacts, reusing your knowledge, right? So having a consistent application model is very powerful. Not only that, today, beyond developing your solution, you need to be able to deploy it pretty quickly. You need to be able to service. And more importantly, you need to track how your solution is doing with your end users to keep them happy. And DevOps have a big play on that, right? You basically make everything automated to save time on deployment, distribution, etc. You do have instrumentation to see how your solutions are doing. And basically, at the end of the day, you are able to deploy your solutions with minimal intervention. And the reason this is important is because the less intervention you require from a human means you can be you can react more rapidly to changes in code, etc. It also helps when you automate quality testing, etc. Okay, all of that you can do with a broad set of tools that allows you to target both Azure and Azure Stack. And also, when we look at Azure Stack, it's also important to highlight the very broad partner ecosystem, which is the Azure partner ecosystem. So we look at the different partners that basically extend Azure Stack with solutions that go from marketplace items to templates that you can deploy pre-baked solutions, which basically means that you spend less time creating and writing code, and then you focus on what is important, which is designing an application that solves your customer problem. Finally, you have an integrated system. The experience with Azure Stack is an appliance experience, where you basically receive this appliance that arrives to your site pre-configured. You provide power, connectivity, and what you get at the end of the day is the Azure portal and the different Azure endpoints, the ARM endpoint. But all your Azure tooling that you like and you are used to can seamlessly connect to this infrastructure. All right. So what those key highlights mean is that when we look at different, the three key scenarios of Azure Stack, which is allowing you to create born cloud-style applications in disconnected scenarios. Those scenarios that I mentioned about, remote sites, remote operations, etc. To also address regulatory and data sovereignty needs. And finally, to enable modernization of applications. All right, so this was a very quick summary of the highlights of Azure Stack. Now, let's go to hybrid, which, by the way, is why all of you came to this session. So the first thing about hybrid is that hybrid has many forms, which means that if I ask each of you what hybrid is, I will get different answers, several different answers. So let's set the stage and let me share some of the definitions that come when my team thinks on hybrid, right? First of all, you have matching resources on both clouds. You create a solution, and that solution may be comprised of a VM, a bunch of resources, and you want to deploy this solution either on-prem or on the public cloud. You can get that template, target a deployment in Azure, or target a deployment in Azure Stack, or vice versa. And the end result is you have matching resources on both clouds. Great. Another form of hybrid is where you have resources spread across the clouds, Azure Stack, Azure Government. And basically, you use the public endpoints for connectivity. What does it mean? Every Azure service, or most of the Azure services, provides a public endpoints that you can consume. So as long as you are operating on a connected fashion, your application in Azure Stack will be able to reach those public endpoints, and as a result, we'll be able to reach components that are deployed in Azure. And then what you do is you use DevOps strategies to basically automate the deployment on Azure and Azure Stack. And you can use basically one template to deploy a part of your solution on-prem. It may be an app service, a SQL, MySQL, a Kubernetes cluster, or if you, in Azure Stack, and then you can use another template to create those resources, other resources in public Azure, and use the public endpoints for connectivity. And lastly, you can have seamless connectivity across the clouds. There are different ways to accomplish that. For example, you could use something like VPN between Azure and Azure Stack. You can use the Azure Network Relay, which also enables you to provide connectivity between both. So those are the three main forms of hybrid that we will use during this presentation. What is very important about hybrid is that hybrid enables a new breed of applications. All of you that are interested in Azure Stack and interested in the Microsoft Edge story, basically you are witnessing a new type of application being born. You're basically building the future. We are providing you the tools for that, right? We are talking about applications that are running harsh environments, that provides insights where things happen with total new form factors. One example, again, our keynote demo, the disaster relief demo, where we demo a prototype and a concept of what will be running Azure Stack in a mobile operation type of thing, right? So again, this is all new. And that's one of the most interesting things about hybrid, which is now we are able to address scenarios that we're not able to address before. All right, so I think the best way for us to talk about hybrid is actually look at what hybrid would look like in real life. And with that said, Let me switch screens. And this demo was born from a customer conversation I had with a company that require data ingestion in a global scale, but data processing locally. Reason why the business that they are is a printing business, a large-scale printing business, where they have printing plants in some areas of the world, and basically to command those printing plants, they do require systems on-prem. But at the same time, they want to design their new on-prem applications in the same model that they currently use in Azure, leveraging ARM templates, all the DevOps stuff, all the good stuff from Azure. So then from that conversation, that was born the scenario that I'm going to describe you. So how do we ingest data in a global scale and then bring this data down on premises to maybe connect with an existing system, for example. There are different ways to do that. What I'm going to walk you through is one way, and this is what I call hybrid using public endpoints. So I do have some services in Azure. I do have some services in Azure Stack, and I leverage the public endpoints to make the connectivity. What you are looking at here is the Azure Stack portal. I will go there in a moment. So the first problem that we wanted to address was the ability to basically ingest data in large scale. How do we do that? There are different ways, and we can definitely leverage the breadth of the Azure platform. So let's take a look. Let me switch screens here. Let me walk you through a few resources I have in Azure. So this is my account in public Azure. I have a storage account with a queue. Here's the queue. I don't have any data on that queue yet. So I thought, if I need connectivity, one way I can leverage Azure queues, for example, with the Azure, the public endpoints. Now, that doesn't solve the data ingestion problem. So for the data ingestion problem, there's one thing I love, flows. Whoever use flow? One hand, two hands. All right, so this is not my product, but it's one Microsoft. So what you do after this session, you go and you use flows. There is a free there is a free option, which, by the way, is what I'm using. It's one of the coolest things that exists for automation of simple tests. All right, so here's what I did. I know that there is Flow, and Flow can consume data from a bunch of places. Great. One of the places that Flow can consume data is OneDrive. Great. So here's what I did. I create a Flow that receives data from OneDrive, all right, from a OneDrive folder. So when a file is created, what happens? A message is put on a queue. So which means that if I go to my OneDrive folder, and I won't give you my OneDrive folder location because otherwise you put a bunch of files there. Anyway, when I go to my OneDrive location, whatever I drop here will end up on an Azure queue. So I solved the problem of data ingestion. I solved the problem of exposing some kind of connectivity to a public endpoint. This is all Azure. Not only Azure, it's Azure and the other Microsoft services like Flow. Great. So let's switch to Azure Stack and see what can we do in Azure Stack. A couple of things here. If I look at one of my resource groups, I have this sample RG1 here for a bunch of resources. And basically, it's a good example of the services you get with Azure Stack today. By the way, what I'm running here is the Azure Stack Development Kit. It's the one node deployment of Azure Stack where you can install Azure Stack in one server for development purposes. That's what you are looking. This is all real. This server is in one of my labs in Redmond. So as you can see here, I have Azure Functions. I also have a MySQL database, a SQL database. This is all Azure Stack services. Great. So let's look at one function here. And I love functions because one of the best things about Azure Functions is that you can quickly write serverless features without a specific development environment, having to compile things. Basically, things just are very easy to design, prototype, and run, right? So I have one function here. It's called function 1. And what this function does is this function is kicked off every time that a item gets in a queue, in an Azure queue. Bear with me. I'm going to cover the connectivity in a bit. And then what I do is simple, select SQL stuff where I insert data into a SQL database table, which happens to be hosted in Azure Stack through our SQL provider. Great. So basically, with this function, I can listen for a message on an Azure queue and then process data based on that. Now, the magic happens here. If I go to application settings, what you will see is that I have a bunch of connection strings here that basically points to my endpoint in Azure, my queue in Azure. And it's hard to see. I won't try to expand this. But one of these application settings, this one here, AZS hybrid demo, points to a endpoint in Azure. That's it. So what I did, I went to my Azure storage account, I got the endpoint, and I configured on my application settings. OK, so let's see this thing running. So what I will do is I will create a few files, drop by my OneDrive folder. They will end up on the Azure queues. The function is triggered by that queue. And the end result, by the way, let me just clear the logs so we have something to watch here. And the end result is I have a table in my SQL database running in Azure Stack that has some data, right? So as you can see, I have 9 records. What they mean is just test data. It's not pretty, but we know there are 9 records here. OK, here's what's going to happen. Let's switch screens now. And a couple of things. I go to my Ignite demo folder. Hey, fish. And here's my text file. This is a hybrid demo. OK? Let me save that. And I'll just move to OneDrive. And now, just to ensure that I get this process as quick as possible, I will run a test here. And basically, this is just force flow to get that message. It will take a few moments. Flow is going to read that file from my OneDrive and then send that to Azure queue. So my flow ran successfully. So now if I go back to Azure Stack, you can see that the function was completed. Right? I have a success message here. And if I go to my table and do refresh, instead of 9 records, I should have 10. And this is a hybrid demo, right? So what I just did, pretty much not 100% from scratch. I had, of course, built the connections before. I just walk you through how you leverage public resources in Azure you use other Microsoft services, and then you connect that to Azure Stack. So this was a quick example of how you do that. With that said, I am very, very excited to bring something to you which you are the first to see. All of you in this room, it's the first time you are the first one to see this, is the hybrid application tutorials. So we are very proud. We've been working in the Azure Stack team to create guidance for you to reproduce these kind of scenarios. And by the way, the one I showed is relatively simple. Anjay have another scenario to show later on the session. But you have resources that can help you design those solutions. So if you go to AKAMS/AZS dev tutorials, that's the landing page you get. We just published a guidance for creating things like, how you do high available SQL databases in Azure Stack, how you do high available MySQL databases, how you do machine learning with Azure Stack, and others, right? So I highly recommend when we wrap up the session, you go and check this out. Also, I'm very proud to say that we have the first release of what we are calling the hybrid sample applications. What you see over the upcoming months is a series of scripts and templates that basically package those hybrid applications. And what that allows you to do, our intent is to just have you kickstart your development. And for the samples, the location is AKAMS AZS hybrid sample. I highly recommend you to check it out. All right, with that said, I really want to get Anjay here on the presentation, because actually Anjay was the person that designed all this content. And actually, if you look at the pull request, there is a pull request from yesterday on GitHub. So Anjay is the man. I will let him take over the presentation and show you some other very cool patterns. Anjay, stage is yours.
Thank you, Ricardo. So today what we're going to show you is Ricardo showed you an example of a hybrid app. And over the last year and a half, I think, we've worked together, the PM team on the Azure Stack team has worked together to figure out, and with a lot of customers, what kind of hybrid apps you would build if you had a blank slate. And after, I don't know, 50, 75 phone calls, hours of research, we came up with 6 solutions that kind of bucketize all of those. All of these solutions are part of someone's hybrid application. These are based on real customer stories and scenarios. And so we've got first hybrid DevOps, cross-cloud scaling, data sovereignty, tiered data, geo-distributed applications, and AI at the edge. That's that cool machine learning guidance that Ricardo was telling you about that was just published. First, let's talk about hybrid DevOps. So you don't realize this, but Ricardo's my manager, so I need to be on my best behavior. So I'm going to take a risk here. I'm a very lazy man. I'm known for a number of things in Redmond. Getting to work at 8 a.m. is not one of them. But hybrid DevOps enables me to be the laziest man I can be, because it gives me a portable cloud-native application and infrastructure. This means that because I have a cloud both in my data center and on the public internet, I can deploy the same thing twice. Or I can deploy different parts of my application, and the best thing is it happens automatically. All I have to do is click a few buttons in Azure DevOps, and it's the same buttons, mind you, for Azure and Azure Stack, because Azure DevOps works with Azure Stack natively. And my application is deployed and tested. I get to use that same tooling. Visual Studio works for Azure and Azure Stack. Azure DevOps works for Azure and Azure Stack, and the Azure SDKs work for Azure and Azure Stack. There's actually a session about that. When is it?
So we had the Michaela session yesterday, and also Shree's session is coming up.
Right.
So check it out. We'll have the session list at the end of the end of our slides.
Sounds good. So there's going to be a deeper dive on this later today. But this means, like, the Azure SDKs aren't called the Azure SDKs, and then we have the Azure Stack SDKs. They're just the Azure SDKs, and they work on both clouds. And again, this allows me to extend Azure to places where Azure can't or doesn't go for specialized needs. Let's take a look at a typical hybrid DevOps flow. So I am a developer. I promise I am. I swear, I know the title says PM. I know how to write code. I promise. But I make some changes to application code and an ARM template, because that's one of the great things about having adopted DevOps is that my infrastructure exists as code. It exists as ARM templates in both Azure and Azure Stack. So I make a change to application code or the ARM template. Great. I check it into Azure repos. The build commences automatically and tests are run automatically. Hopefully, I'm a good enough developer that it passes on like the second time. I'm not even going to go for the first. And then the deployment is orchestrated by Azure DevOps. The application, in this case, will run an app service on both Azure and Azure Stack using the native Azure DevOps tooling. Let's look at how we actually implement this. It's a bit more complex. So I have two Git repositories, one for app code, one for infra code. And of course, everything on the VSTSI, which should be Azure DevOps, is hosted in the cloud. The branding people are going to be very unhappy with me for that one. So we have, and of course, everything is built in the cloud. There's no need for me to run a build server on premises. All the builds and testing happens in the cloud. Once builds are done, that the release is copied to a public file share that I can access. Now, Azure Stack sometimes may not be on the internet. There may not be a way to publicly contact it from the outside world. So we have a little Trojan horse that goes in the back door, an Azure DevOps build agent. This is an agent that is a VM that sits there and gets instructions from Azure DevOps and runs the same steps it would run on Azure in Azure Stack. And all of this depends on that ARM template and that web app being consistent across clouds. Now, that's the tenant side. On the Azure Stack admin side, there's a few dependencies. You want to make sure you have the right, say I'm deploying some VMs, I want to make sure that my administrator has put the right VM images into my Azure Stack, that they've set up their offers and plans so I don't run out of quota in the middle of a deployment, or that I've set up all the right resource providers so I have the correct PaaS services that I'm looking for. And just some best practices. We want to use service principals for authorization and authentication to each environment. We use self-hosted Azure DevOps agents for faster build and deployment times, because it doesn't have to resync all of those packages that I've already downloaded. We want to make sure that we can talk between Azure and the agent running on Azure Stack, so that way we can run deployments. Like I talked about, ensuring that all of the images and services are available that you want to use, so that would be something an administrator would take care of. And use API profiles to minimize the work to deploy to two environments. How many of you are familiar with API profiles? All right, that's a higher number than I expected. Great. So API profiles are a way to standardize API versions across Azure and Azure Stack, so that way when you write code to a profile and an Azure Stack supports that profile, you know it's going to run in both places. And we'll cover more on that later. Next, we have cross-cloud scaling. At some point, this was called cloud bursting. You may know it as that. This means that when I work in an industry that has a peak season, think retail around the holidays, my application can scale to meet customer needs. There's no, oh no, I missed out on this great deal on a TV because I can no longer load the page because everyone else is trying to buy the same TV. The load scales automatically because we have a cloud environment. The cloud makes the best use of the resources available. There's no need to rack and stack individual hardware every time you run out of capacity. We have increased flexibility because it's consistent. The same app that I can write in Azure Stack can expand and scale into Azure with little effort on my part. And again, it's a consistent experience across the cloud boundary. Developers have the same experience, and your customers will have the same experience. So let's again look at how this is implemented. So I have a number of users trying to access a web application. First, they hit a traffic manager, at which point traffic manager gives out DNS names in return depending on certain criteria. And I have a web app deployed in both Azure and Azure Stack. As requests build and the rate of traffic increases, there's a function that's triggered that tells that traffic manager to start diverting traffic to Azure to take load off the on-premises server. And again, it's the same web app in both places. The web app is deployed and spun up and scaled automatically because I have telemetry that's consistent across clouds and can make that decision. And using a serverless function, I can easily start that up. We'll actually show you an example of this later. Here's how it's actually implemented. So I have a traffic manager with a DNS server. I need to control the DNS records for my domain. And what I've done is I can set up a custom domain that sits outside the traffic manager and then configure an SSL certificate chain so that way, again, my customers don't see any difference. They get a consistent experience that they are logging onto the same trusted site that they're used to. Of course, I have hosted and Azure Stack build agents to make sure that my application is deployed, that whenever this kind of builds on that hybrid DevOps story. Wherever I have a new application version, I roll it out, it gets rolled out to both clouds at the same time. Or I can stage it. I can roll out the new version to Azure Stack and then roll it out to Azure once I know that it works fully. It gives me all kinds of flexibility to bring new features to two places to my customers. So some considerations and best practices. We want to be using SSL and proper certificates and domains to maintain a secure connection. This is a bit harder than it sounds because you have to make sure everything lines up exactly. So make sure you do your research with your SSL certificate provider. Use an Azure Pipelines agent on each environment to deploy faster. And make sure that you have enough app service workers on the Azure Stack to support the increased traffic if you are hitting a peak load time. This is important because if it can't scale out, if it doesn't scale out fast enough, then customers will face denial of service. Also very important, ensure that the Azure Stack is routable from the internet. Make sure that customers can access the Azure Stack and access the website. And for true cloud native scaling, Azure supports auto-scaling of app services. Make sure you set that up so that way, once you've expanded from Azure Stack into Azure, you get some more headroom before things start breaking. Let's talk about data sovereignty and data gravity. A number of the use cases we heard when developing Azure Stack were, my data has to sit within a certain border. It cannot leave the country. It cannot leave the data center. It cannot leave the box under my office desk. Any of these things. So what we decided was that Azure Stack would bring applications and services to where the data is generated and resides. For example, a factory floor. Factory floors generate tons of data. They also tend to be in rural areas where there's not the greatest internet connection. So we bring the application to the data. This allows us to create an application that spans cloud boundaries. Maybe I collect some data in Azure, but I have private data in Azure Stack. And I can merge the two for a more enhanced customer experience without violating, regulations of any kind, corporate or, federal, state, provincial, whatever. And of course, this allows me to meet my compliance requirements. So again, let's look at how the user flow works here. I have an application where data collected has to stay on premises. It cannot exist in the cloud for whatever reason. Azure is a very compliant cloud, but there's a lot of corporate regulations that still need to change. So I am a user, and I'm filling out an application, or I'm filling out a form in Azure that's running on app services. Once I hit submit, the data passes through a site-to-site VPN created between two Azure VNets into a SQL database residing on Azure Stack. At no point was my data ever at rest in the public cloud. It's encrypted the entire way through to the private cloud, where the applications that work with my data on premises can use the same model they would have used in Azure to be just as productive with that data. let's look at how this is built. So first of all, especially this one that requires you have Azure Stack with publicly routable internet endpoints, you want a jump box because public IP addresses tend to be very limited. So this way I can access from Azure all of the resources that I'm deploying and working with across both clouds from a single remote desktop session if I need to. At this point, I have a virtual network that's split into two subnets, one for the application and one for a gateway. Public IP for a virtual network gateway, and a web application that's connected via point-to-site VPN to the Azure VNet. You may know this as network integration in the app service menu. Once I have that set up on Azure, I create something very similar on the other side in Azure Stack. I deploy a database server, and into the subnet, I have a VNet with two subnets, an app subnet and a gateway subnet. And I set up a site-to-site VPN between the two. So I have two VPNs here, just so we're clear. I have a point-to-site VPN from the web app in Azure to the VNet in Azure. And then I have a site-to-site VPN from the VNet in Azure to the VNet in Azure Stack. Some considerations and best practices. These considerations and best practices, I have built all of these solutions and tried them out at some point. And so these are problems that I have faced or things that have had me scratching my head for a little bit until I figure the problem out. So I'm just trying to save you some time. So make sure that none of the subnets in the virtual networks overlap. If they do, you'll have some interesting routing problems when you connect your VPN. Use ARM templates to reliably deploy infrastructure machines. Things that, like that jump box or the SQL VM that I talk about, deploy all that with infrastructure from code. That way, if I break it, I can delete the entire resource group and try again. No harm, no foul, easy. Ensure that Azure Stack is installed in a compliant manner, so that way you're not breaking any regulations with the data stored on there. Ensure that the Azure Stack is routable from the internet, because the VPN has to traverse the internet to get between Azure and Azure Stack. And use a strong pre-shared key to set up the VPN, just to make sure that the data stays secure all the way through. Let's talk about AI at the edge. This is kind of the fun one. So again, we all are about bringing the data and the intelligence to where the application resides. But AI at the edge adds a new wrinkle. It allows some data to flow back from Azure Stack to Azure, from the private to the public, in an anonymized and compliant way to improve a machine learning model. This means I can train the model at scale in the public cloud and then deploy it on premises in not one, but several private clouds. For example, think of a platform on the ocean, a drilling platform. They have lots of use cases for machine learning. They want to make sure that they're drilling in a correct manner, that they're not causing trouble, that they're not going to break their equipment. That takes time and money to fly out there. This way, they can get the same benefits of machine learning in the public cloud in a place where the public cloud connection is either high latency or not always available or very expensive. And this allows us to get faster insights. Can the crew on the platform see the drill bit's going out of the way, or it's overheating quickly, or it's more prone to failure, and that way they don't have as much downtime because they can proactively order a replacement. Let's look at our flow here. This one is a little bit more complicated. So I have a lot of test data. It's anonymized, it's compliant, and I have a data scientist who works on this data. They train the ML model in the cloud using cloud-native tools and containerize it. This means they use Azure ML and maybe Azure ML Workbench. It means they use the power of the cloud with HD Insight clusters or a GPU-based training cluster. Once that model is generated, it's put into an Azure Container Registry. And because, if you looked at the Azure Stack blog announcement this week, we announced a Kubernetes cluster marketplace experience for Azure Stack, where you can enter some details, and then about an hour later, you get a fully functional Kubernetes cluster. So using that, We deploy a Kubernetes cluster to Azure Stack, and we deploy the model to that cluster. Input on the local side from telemetry, people, whatever, is scored against the model. And just like in Ricardo's application, the insights are placed into a queue. But the queue is actually on Azure Stack. A function takes the data from that queue, anonymizes it, strips out any data fields that might be protected, and sends that data to Azure. This means that whenever there's connection available, it can upload a batch of data, or it can just have a constant stream of anomalies or trends, summaries. This cuts down on the amount of data that has to flow through a round-trip connection to the public cloud, but gives the data scientists and the people on site the same experience. It also allows for someone, say, at a central office to get compliance and insights on all of their entire fleet. Of course, data is archived and possibly uploaded in an anonymized manner to a storage account, and the process begins again. The data scientist gets the new data and then creates a new model. This allows a data scientist to get insights from data they may not have been able to get to before because it was behind a slow internet connection or no internet connection. And so it allows for greater, faster, and better insights. Let's look at how we build this one. So in Azure, the data scientist uses Azure ML. And they use a data science virtual machine, which can have GPU or a cluster of them to train their model. They have a machine learning experimentation account to store the models and to manage all of their clusters on Azure, and a machine learning model management account to store and keep track of the different versions of their models and how they've trained them. This produces a container image which goes into an Azure Container Registry, which is protected by usernames, passwords, secrets, and then deployed into Kubernetes. And Kubernetes is very powerful, but you can deploy it in a highly available manner, so that way it can deal with all of the data coming from the resources on premises. And of course, this entire thing is orchestrated by Azure DevOps. Because the developer, even though the data scientist is the one creating the containerized model, can create a pipeline that says, when this person commits a new model to this registry, deploy it to these 5 machines as a test, and then when you get back good data, deploy it to the rest of them. So the data scientist doesn't have to worry about, how is this work that I've done going to be realized in the world? And the developer doesn't have to worry about, hey, do I have to email this guy and ask him where his latest model is? And he can point me to the share, and I can do the thing and push it somewhere. All of this is orchestrated for them. And of course, all of those functions that we use to anonymize the data and put it into the queue and send it to Azure are also built by that developer and deployed in a DevOps manner through pipelines, using a build agent on each Azure Stack. This can also be done in an offline manner. Azure DevOps can generate a package which runs an installer, which gives that same functionality and those same functions to someone running in a disconnected environment. The loop still works, even if there's no internet connection. Some considerations and best practices. Make sure that Kubernetes exists and that it's properly networked. Networking Kubernetes can be a little bit hard to understand, but once you get the hang of it, it's pretty easy. But it did frustrate me the first few times. Plan for an unreliable internet connection when you're sending those anomalies or data to Azure or when deploying a new model. And because you want to make sure that even if there isn't a connection right then, that your new improvements and new data can flow back and forth. Appropriately scale the training cluster in Azure. Make sure that your data scientist has enough energy and room to work. Make sure that they're not struggling to train a model and not get those insights because they don't have the resources. That's the entire point of training at scale in the cloud. And ensure that the scoring application is protected against denial of service. Make sure that there's enough headroom and that it's scaled properly so that way it can answer all requests for analysis. Next, we have geo-distributed applications. This is very similar to the data sovereignty one, except the entire application, the application you're routed to depends on where you are in the world. And so if there's a region of the world that isn't able to use the public cloud just yet, we can set up an identical application for them using Azure Stack and just intelligently route them based on maybe where their account is, if they have an account with the German version of the company, or the United States version of the company, or even their location in the world. This one's fairly simple. Users attempt to access an application. Again, our friend Traffic Manager just returns, can use geographic routing to return the application that's closest to the user, be it Azure or an Azure Stack. Again, this one's fairly simple. It's Traffic Manager, DNS, and the identical application on a number of machines. In the back end would be a hybrid DevOps scenario setup, deploying the same application or different compliant versions of the application at the same time to make sure that all of these sites are up to date. Some best practices. Again, make sure that SSL certificates and domain names are properly configured so that way users get the same seamless experience. We didn't really cover scalability, but make sure that that the environment scales based on the number of users per each location. Make sure that it's scaled appropriately. Again, I talked about using a DevOps pipeline to make sure that the same application or the compliant application is at the right cloud. The right application for the right location and the right cloud is important. And again, you can either route your users based on, say, what region they created their account in or their service in, or just use simple geolocation provided through Traffic Manager. So let's look at tiered data for analytics. This is kind of the one Ricardo did, but backwards. So we can collect data on premises, do some pre-processing, pre-analysis, and derive local insights, and then send fleet or summary insights back to the public cloud for analysis. Again, this brings the cloud and the application close to where the data resides or is generated. Let's take a look at this setup. I have data probably from a number of devices. It flows into a storage account, at which point a function analyzes the data for compliance and anomalies. Is a certain sensor reading above a certain level? Is there credit card data in there? And it presents local insights to the user based on those anomalies or data. At which point, it then also strips out the data, strips out the non-compliant fields, puts it into a queue. That queue activates yet another function, and then puts that data into a storage account in Azure for further analysis by the central team or by someone who can use the public cloud. A common trend, if you haven't noticed among all of these patterns in Ricardo's demo, is that we like to use functions a lot. It makes hybrid development really easy when I could say, hey, from an endpoint, trigger this, and then make this happen on an entirely different endpoint. And it takes me less than 100 lines of code to do it. Functions are a great way to wire together 2 or more different clouds. It makes life so easy. Again, how we built it. So again, there's just a number of storage accounts, some for archival, some for anomalies, some for processing. There's functions that, again, strip out, analyze, and collect the data. And then a couple of applications that display local and global insights. Some best practices. Plan for intermittent or disconnected scenarios. Make sure that your function knows, hey, if I can't access the internet now, can I do it later? Ensure that non-compliant data is stored encrypted at rest, because you want to make sure that that you're not breaking any regulations. And scale your Azure functions and applications appropriately to handle the throughput. Now, given that, let's demo a complete hybrid solution that combines the data sovereignty with the VPN, scalable web application, a cross-cloud scaling, and the other one, cross-cloud scaling and tiered data. So let's take a look. There. So who was in the U.S. about 10 years ago? Okay, cool. Y'all remember when the Affordable Health Care Act came out and healthcare.gov launched? And it fell flat on its face? Yeah, it tried to launch. Okay, we'll go with that one. So this is one of those things where we have Northwind Health. They're a totally fictitious insurance company. And they, every year, have open enrollment, which means everyone tries to log in and sign up for their plan at the same time. And more often than not, about 10 minutes in, something falls over, and someone gets woken up at 2 in the morning because it broke. And they'll have to drive to the data center and think about how to fix it. And they get to explain to management why there was downtime and why they lost X many $1 million. What we've decided is that what if they didn't have to just use the on-premise hardware to be compliant, but they could use the public cloud? Their web application that people use to sign up for insurance could scale into the public cloud, but data is transmitted and kept at rest in the private cloud. Let's take a look at how this is built. So first of all, I'm going to start simulating load right now. So as you can see, right now the page says, it's using a traffic manager URL, northwindhealth.trafficmanager.net. You can feel free to sign up for insurance. I can't guarantee any coverage, but go ahead. And it says this page is loaded from Azure Stack. Big blue banner. This is because it's before open enrollment has opened. Let's open open enrollment. I'm just going to generate a bunch of load. And while that's happening, let's look at how this was built. In Azure Stack, I just have a VPN gateway that we talked about, a web application of your virtual network, local gateway. I have a DevOps VM to deploy my application reliably and seamlessly whenever I make updates. And I have a SQL VM that runs my database. That's all that's in Azure Stack. It's a web layer and a database layer, and a VNet that connects to Azure. Let's look at what we have in Azure. I have the same web app. It's identical. I have VPN set up. And I have a couple of jump box VMs for debugging. But here's the fun stuff. I have a traffic manager set up. Traffic manager just has 2 endpoints. It has, as you can see, the Azure one is disabled. Traffic hasn't hit the required threshold yet. There's no need to route traffic to Azure. But the Azure Stack one is enabled, which is why you get the page that says, this page is loaded from Azure Stack. And I have an App Insights page. Telemetry is a hugely important part of cloud-native development. What I did was I gave every instance of my application deployed on Azure and Azure Stack the same key for telemetry. So I can see the requests coming in. Thankfully, none of them have failed yet. But you can see the requests have increased. So let's go ahead and look at a live metric stream. Oh, it gives me, OK. So as you can see, the request rate has increased. And I can see the requests. See, as you can see, this one's running on Azure Stack, WW, and it's getting about 5 requests a second. And there's nothing in Azure just yet, the RD servers. But I can get live metric streams. Fun fact is, sometimes in sample telemetry, because I have fields on the form that say things like social security number and credit card number and address, I get like little phishing attacks every now and then, and I'll see a bunch of failed requests because people think there's actual valuable data on here. And it's a nice little honeypot to look at. But this happens, and I have an alert configured that says, where are you? Whenever I hit a certain threshold of traffic, in this case, 2 requests per second over 5 minutes, to load, I need to fire a request. And so I have 2, scale to Azure and scale to Azure Stack. Each of these kicks off a webhook that runs a function. This function, to be precise. And all this does is, using Azure Authentication, get my traffic manager, and depending on the location it's given, just deploy it to Azure, scale in, enable or disable the traffic manager endpoint, and turn on or turn off the web app in Azure. That's it. So let's see if I've hit my traffic saturation yet. If not, I'll do it manually so that we don't have to sit here and watch me, refresh a bunch of times.
Looks like no one wants to sign up for your health insurance, Sanjay.
I know it's terrible. They really shouldn't. OK, we'll just go ahead and run it manually. So I'm going to go ahead and fire this. Action, Azure, scale out, run. Let's clear this.
look at this solution, one of the beauty of hybrid is that you can leverage all the breadth of the Azure platform, which includes Azure Stack. Right? In this case, Traffic Manager is in Azure. So this is another showcase of you leveraging services on different places for the benefit of your application.
Right. So I actually, if you noticed, I jumped the gun. The alert was activated. And the Traffic Manager has changed to enable it online, to enable the Azure endpoint. So let's see if I can't go sign up for health insurance and get a different page. Let's try Chrome. Sometimes DNS gets cached across instances, and it takes some time to change. There we go. This page is loaded from Azure. Same endpoint, same experience, and the customer will never know if that banner wasn't up there. So let me sign up for health insurance. I've got it pretty pre-populated. Show some plans. I'm going to buy a gold plan. I'm going to enter my name. Done. I have a lovely social security number. Go ahead and take a picture. I have some nice income. Submit an application. All done. I've enrolled for health insurance. Now let's see what actually happened. So if you notice, I talked to you about a jump box earlier. This is running on a public IP in Azure, because getting it directly. So as you notice, I'm not using an ASDK system. I'm using an actual Azure Stack that's been deployed into an Equinix data center in Seattle. And public IPs are fairly expensive, so I can't exactly charge those to my corporate card. So I use Azure, and I deploy a jump box in Azure. I use that jump box, and then I go ahead and remote into my VPN, into my SQL environment in Azure Stack. Note the private IP address. At no point is this SQL box on the public internet. And now I have some registrations. I've successfully signed up for health insurance, and again, my data was never in the public cloud at rest at any time. I was compliant with my industry and company regulations, although Azure is compliant with a number of regulations, and it was entirely scalable. It responded to the increased traffic, spun up an instance in Azure, and gave me the same experience as a customer. Let's go ahead and look at kind of the building blocks there. So I have a complete hybrid solution. Users are directed to the compliant cloud, and data is stored in Azure Stack. Again, we have a VPN that has point-to-site from the Azure App Service to the VNet, and then a site-to-site from the VNet to Azure Stack. We have an app that's kept up to date by Azure DevOps that is deployed to both the public and private cloud. All right, Ricardo. Ricardo will talk to you about. Sorry.
That's awesome, Ajay. Much better than my pretty simple app of ingesting data.
It's not. I mean, I did get health insurance, but
Yeah, I mean the health insurance is not high quality, but the app is nice. But it's. I think that what I like about this demo is that it really brings, as I mentioned earlier, hybrid has many forms. It's just this demo that Anjay just walked you through, bring true reality. Bring the point of, accessing the public endpoints. It's very straightforward to do. But if you indeed need direct connectivity, you can also do that, and it's pretty feasible. And we do have, it's much better now that we have the guidance to do that. So again, I highly recommend you at the end of this session going through the artifacts that we had created. And we love your feedback, and we are going to be publishing many other sample applications.
Yeah, so when Ricardo was talking about the guidance earlier, that entire use case setup that I just demonstrated, you can deploy it in an entirely automated fashion from what we published on GitHub. You enter your credentials, you enter a couple of domain names, and it deploys it for you in a couple of hours. So please give it a shot. Thank you.
Yeah, so for some considerations that I like you to think when you are designing such types of hybrid solutions is, I think, first and foremost, When we look at Azure, that is Azure Resource Manager. Azure Resource Manager provides you the ability to create templates. It is the gatekeeper, right? So the lifecycle of resources is controlled by Azure Resource Manager. And basically, your tooling, SDKs, etc., target ARM and use that to actually perform the actions against either the Azure Public Cloud or Azure Stack. Great. Now, when we look at the Azure Cloud, there is a very extensive set of capabilities. And not all those capabilities are available in Azure Stack. So bear in mind that, take that in consideration. And the beauty of this is that ARM and the tooling is all can have the ability to self-describe, which means that from the tooling perspective, you can query the capacities of your endpoint and understand if such a resource exists there or not. Now, for resources that exist in Azure and Azure Stack, keep in mind that there may be a difference in versions, right, in API versions. So in the past, it's funny to refer to Azure in the past. In the past, in Azure, you would always have to specify not only your resource that you wanted to create, but also the API version of that resource. When we introduced Azure Stack, we came up with the concept of API profiles. And what API profiles are basically they are an artifact to manage a version difference between Azure and Azure Stack and the other Azure clouds. API profiles are implemented in PowerShell, in CLI, in every SDK. And what API profiles look like is, if you are in PowerShell, you issue a command, use -Azure RM profile. You will specify the profile you want to use. And basically, what happens when you do that, if you specify what we call the hybrid profile, your code will work across Azure, Azure Stack, and the sovereign clouds, because the hybrid profile is a profile that targets all the clouds and does exactly what I just described. It does hybrid. You can also use the latest, what we call profile latest. And when you are on the tooling and you do use -Azure RM profile latest, it means that you are using all the latest capabilities of the Azure cloud. And finally, there is another type of profile that we coin, which is what we call the dash profile. So there is dash hybrid, there is dash profile. And dash profile basically is a middle ground between the cutting edge capabilities and the capabilities that are supported across the Azure clouds. The beauty of the hybrid profile is that, again, your code will target not only Azure Stack, but you target the sovereign clouds and Azure. Because what we do under the cover is we only expose the capability that all the clouds support, which is very handy for you when you are writing your code. And want to make sure that this code runs without changes across the clouds. Great. So it's also important to highlight the marketplace capability in Azure Stack. So you have content from the Azure marketplace that is curated and available for Azure Stack. Leverage that. If you are an Azure, if you are an Azure Stack, if you're developing to Azure Stack, ensure that you are referring to the marketplace for pre-built solutions. That is everything from MySQL databases to Windows Server images to Linux and LAMP frameworks. All of that is available on the Azure Marketplace, so I highly recommend you checking it out. And also, when we talk about development and tooling, there is a very, very broad set of capabilities in the Azure platform that you can leverage in Azure Stack. Things like Visual Studio, Visual Studio Code, all the different Azure SDKs. And again, I think we made the point clear on our demos. You use the tooling that you are familiar with, and that tooling targets both clouds. Also, you can do something like Anjay did, which was using instrumentation, storing instrumentation in the public cloud, and based on that instrumentation, make the choice to change the behavior of your application. So there is there was a session on tooling that happened yesterday, and there is an upcoming DevOps focus session that I highly recommend. So to get started, I highly recommend when you walk out of this door, check out the Azure Stack Development Kit, aka MS/ASDK. Check out our quick start templates on GitHub. The hybrid tutorials, thank you, Anjay. That's pretty cool that we released that. Also, the end-to-end hybrid application sample, please give a try. Submit feedback. You can even put a pull request if you want. You just be nice to Anjay, and he will approve the pull request. And so just a recap of the sessions. So yesterday we had Azure Stack Overview and Roadmap. We have some industry solutions with Azure Stack. There was Breakout 2373 for focusing on getting started as a developer. And there was also a end-to-end Edge session that included Azure Stack, Databox Edge. That was yesterday. And upcoming sessions, please watch out for the upcoming Azure Stack sessions. There are several cool sessions. There is the DevOps session that Sri will be presenting. There is also a one focus on machine learning applications for Azure Stack, and many others. So I highly recommend you meeting the other members of my team. And at this point, I like to do two things. One is really to thank you for staying here with us. It was a deep session. We went deep down on architecture that is not that doesn't fit in a short explanation. There were many diagrams, and I appreciate you staying. Hope the information we provide is useful for you to design the next generation of hybrid applications. So thank you for staying. And also, before I open Q&A, we are running out of time, but we'll take some questions, and then we will be here in front for a while. Please evaluate us. So if you like us, thumbs up. If you don't like us, you can always do that, so we don't ever come to Ignite. No, we don't want to do that. So we want to be back. So thank you again. And we'll take a couple of questions on the mics. And then we'll just move to the floor to give space for the next presenter. Thank you.
Is this on?
Hold on.
We can always repeat the question.
Hello. So by the way, it's great that you've encapsulated the examples within Azure and Azure Stack. The reality is most people are going to have an existing infrastructure, like for SQL, for example, or large storage environments and things like that. Mm-hmm. They're going to use other cloud providers for certain things as well. So can you talk a little bit about more hybrid
Mm-hmm.
cloud?
Hybrid 3 times. So I'm guessing you're saying how can we expand the definition of hybrid, not just include the two Azure clouds, but other environments you might also have access to. Got it. Okay, so I mean, at that point, it's just a matter of orchestration. So you could totally have an on-premise SQL server as long as it's accessible through a VNet. You might have to, through that VPN, but you might have to just, instead of VPNing with an Azure Stack, you might have to have a separate VPN with your corporate network. Or if you want to use another cloud provider, that's just a matter of you adopting their SDK. And it'll be a little more difficult because our tooling is designed for our products. But you could totally use another SDK and access it through the to use Azure Functions. Or it's just, hybrid is really a matter of making sure you know where you want your app to go and knowing the tools and the endpoints to get there. So that means using the right SDKs, the right services, and then just breaking up your app in ways that make sense to you or your organization. So hopefully that makes sense.
No, it does, and that's what I was kind of looking for. Is it's not relegated just to this system. It is extensible. You just have to know the rules.
Exactly.
And I think it was a great question. Pretty much what we show, you could replace that on-prem SQL database for an on-prem fill blank Oracle, whatever, right? Because your Azure Stack appliance, you have, as long as your Azure Stack appliance can have access to your existing database, you're fine. With the public endpoints, you could use SDKs for other public endpoints and use the same approach. So nothing prevents you to interconnect with other on-prem and cloud offerings. Thank you.
Thank you.
So summarize the question is, there is these hybrid scenarios, the scenario where we have connectivity. Now, how about an offline scenario? Can you do that? And the answer is yes. So you can deploy Azure Stack on a place where you have no external connectivity, on its own if you want, or together with that local data center infrastructure. So you can do that. And then you will leverage the capability that is inside Azure Stack. So the answer is yes. Azure Stack can be deployed on what we call a disconnected scenario.
Do you have to originally be connected first, or can it be, you can set it up completely disconnected?
You can do it entirely disconnected.
That's
Even
very
deployment.
cool.
Yeah.
So the deployment can be disconnected.
That's very cool.
Yes.
Thank you.
Thank you.
So the question, how you manage updates? Yes, so there is a procedure for you to get access to the update packages and load those update packages on the stamp. All right, everyone. Thank you so much for staying. One last thing. On our booth, please go check it out. We have the entire team there. And we do have the SUV that we feature on that keynote video with an Azure Stack inside. You gotta go check it out. At least take a selfie. You won't regret. All right? Thank you so much.
Thank you.